Okay, so this is going to be the ultimate lesson in giving an elevator speech on 30 seconds notice. Where's my colleague with our company, our CFO? I just met him. Is he still here? I didn't want to surprise anybody, but Omed literally just texted me and there's been a family emergency, so he had to scoot. I've known Omed for a little bit, or for years before at Medtronic, and just invited me on as our Chief Scientific Officer. And so, got the slides here, so hopefully can cover this pretty quickly. So the company is Smart Implant Systems. Its unique value proposition is in the area of pain, chronic pain, back pain. Pain is mega billions, we know that. But the key, of course, in the scientists talking about pain is not pain, is not pain, is not pain. It's subjective and it's different, and there's different components. There's your mechanical pain, and there's also what we call neuropathic pain, which is when damage to the nervous system makes our perception of sensation and pain altered. And so what most patients suffer is a combination of both mechanical pain, nociceptive pain, and this neuropathic pain. So you get a disc implant, as this is our product here, to repair degenerative disc. You might relieve the mechanical pain, but the neuropathic pain persists. The business models today do not allow for easily an orthodox to be adding neuromodulation to a mechanical treatment. They know mechanical, they don't know neuro, and the reimbursement and the business structures today just don't make it that friendly for an orthopedic doc to also be playing in the neuromodulation space. The unique value proposition of this invention is to add an active implant to a fixed mechanical implant so that you can address in a patient the mechanical pain and their neuropathic pain. The device will be attached to existing type of fixation technology or interdisc material, and then basically will be an active energy implant, which would be using RF as the modulating source of energy versus traditional electrical or ultrasound. And basically, you know, when we think about the opioid epidemic, that's a big value of this therapy too, is in its pandemic, you know, across the world, but basically is able to address that by intervening early with neuromodulation, offsetting the need when the opioids start. The pain isn't relieved because it will never relieve neuropathic pain, and then you get the addiction and they come back for more surgery, et cetera, et cetera. So the active implant will fit into the value proposition or value stream of existing orthodox and then complement the unmet need. In this failed back surgery syndrome is one of the main indications for neuromodulation today, which globally what is $4 billion for neuromodulation. And so the reduction of the opioid use is a main key. Our roster, as you can see here, is built up with some experienced folks in the field in the relevant areas and also the ortho space. We're just getting started right now. We have some initial prototypes and ideas. We're going to actually leverage the University of Minnesota, which is part of my multiple hats here at the university, outside of the company, to use our preclinical and clinical resources and even some of our technology resources to make this happen. It is unique. Kind of funny, I know the story even though I'm just new to the company because it is an unmet need. And it's funny that business models and big players like Medtronic couldn't figure out how the revenue could go from the spine business, which is related to pain, and vice versa. So basically this is filling a real known unmet need for the patient, but also the business situation where revenues could be easily sorted out. This first period is up to $1 million for the initial period. And then, of course, raising as the clinical needs, the usual story would ramp up. We'll be doing our preclinical work and you know, starting to leverage our first in human earlier than later. And that's a new model here at the University of Minnesota. We have to leverage that early first in human. And that will hopefully de-risk the investment and make this next phase a lot easier to get to. So thank you, FAST, and on behalf of Omed and the team, thank you.
Hi, it's me again. From your perspective, you've got the technology of the disc, implantable disc, and then the neuromodulation component. Where's the IP that ties those two together?
Yep, there's a unique IP, in fact, literally coming on in the process of reviewing it, and that's going to be one of their toughest hurdles is we to look at that, is it looks like there's a good position to have that together, and RF also seems to be part of that uniqueness, and that's why we're going with the RF versus electrical, and so that's one of the parts that make it a little more unique.
Who actually implants this?
This is a very good question. It's going to mainly be in orthopedic, because that's where the value chain for the mechanical parts are. There's been a continuing effort to get your pain docs, which would be your anesthesiologists, working together. But it's also going to be more attractive to neurosurgeon orthos because they'll get the neuromodulation side. But it's going to be mainly that ortho and / neurosurgeon ortho.
Anybody else? One last question then is, how do you titrate essentially the RF frequency to the patient's pain? How does that work?
Very good, and also the key now is patient-tailored, customizable. Today's therapies have often been a constant frequency electrical stimulation. Big research in the area is that there's going to be more biological patterns of stimulation, and this device we're going to be testing on some of those patterns that it will be detected against the patient's need and perception, and so that it will be titrated to their benefit, and that's how it will be. But they won't be required to be fixed, constant waveforms. They'll be unique patterns. Thank you.